Hey guys, Jimmy Song here for Off Chain. I have a special guest with me today, Matt Corallo, core developer. Welcome to the show, Matt.
Hey, thanks for having me.
Yeah, I mean, there's a lot of stuff going on. It does feel like with the price decrease and everything else that a lot of people are getting to work, and you're certainly doing your share. Can you tell us a little bit about what you've been up to the last few months?
Yeah, I mean, I think that's definitely an accurate characterization. I mean, there's a lot of people, after 2x blew up and after kind of the BCH split and the price being where it is, everyone's kind of got time for once to actually sit down, get some work done. It's been really nice. So I've been doing a bunch of random stuff. I started a Lightning implementation, which I drove along a ways. Been a ton of great progress been being made in Bitcoin Core. And then, of course, also, obviously, I've been working a bunch more recently on new mining protocols and better ways to communicate between pool servers and Bitcoin D and Asics and mining farms and optimization and all kinds of fun stuff in that space.
Yeah, I mean, we're going to cover all of that, but I think our audience might be curious because you got into Bitcoin at a fairly young age, and I think that's one of the things that's kind of mind blowing for me because I've been like a software developer for like 20 years, and like it took me years to wrap my head around this stuff. How did you get into Bitcoin? I think you were like 18 when you made your first commit or something like that. Like what drove you towards Bitcoin at that age? Like I remember when I was doing it at 18, it wasn't what you were doing.
Yeah, I think it was like 19 or something like that. Yeah, I mean, I don't know. I mean, I think it was very interesting, obviously, at the technical level. I wasn't much of a software developer, but I knew I knew my way around a computer and knew a little bit of something about programming. Um, the software was also really bad, so I could contribute without being too terrible. Uh, the Bitcoin D Satoshi era was not good code. So even though I was also bad, it's fine. Um, and yeah, I mean, I think the whole like concept of providing this alternative financial product for people who need it and places where it can provide value is really fascinating. Still small percent chance that it works out and like becomes what we want it to be, but I think if it does, it's would be huge.
Yeah, a lot of people don't know about the initial state of Bitcoin D, and I think that's something worth diving into a little bit because, a lot of people sort of worship Satoshi as this like God walking on Earth or something that created this perfect system. When in fact, if you actually look at the code and all the bugs that are in there.
I mean, their code was like very much the kind of hack together kind of crap where it works. And then the second someone else starts touching it and doesn't have every little piece of everything in their head the entire time, it just falls apart, starts deadlocking, and like all kinds of bad things happen. It wasn't well-structured code, but it mostly worked. It also, I mean, like the massive amount of effort that has gone into being aware of all of the different types of DOS vulnerabilities that you can have in a system like this, which is actually relatively novel. Over the last number of years is a huge part of the work that's gone into Bitcoin Core, right? Because there's all kinds of interesting different ways you can have vulnerabilities here that normal software projects don't think about, right? If you have a case where a node can get stuck and might not find the best chain by some attack that you're able to perform, then you could probably steal unlimited amounts of money from a Bitcoin exchange. And so these kind of vulnerabilities can potentially be very serious, but also aren't something that most people spend time thinking about. And they're definitely not something that were sufficiently handled in the Satoshi era code, let's say.
Yeah, that's one of the other things is that early on it was actually quite centralized with alert messages that were signed by Satoshi and things like that. And things have evolved. What are your sort of concerns from a decentralization standpoint? Like, what are some possible centralizing forces at work here that we need to be very aware of as a community?
I mean, I think I have a very different answer to that question now than I did maybe a year ago, right? A year ago, it was a very long list of things, and these days it's much shorter. I think from the various fork attempts, 2x being kind of chief among them, and the UASF, all of that stuff, I think we learned a lot about the Bitcoin community, and I think we definitely set in stone certain elements of decentralized decision making and kind of consensus required for consensus changes to the Bitcoin protocol, which I think answered one of my biggest concerns, prior to a year ago in a pretty big way, which I think is great. There's still a lot of different other ways that things are centralized. There's still a lot of centralization in the way people interact with Bitcoin, and that's okay. That's going to exist, but making sure that the user experience of someone who's on a wallet where they hold their own keys versus the user experience of someone who's on Coinbase is as close as we can get it. Obviously, a centralized thing that deals with key management for you has a huge advantage to begin with, but making sure we can get it as close as we can is definitely really key and will be really key going forward. And then obviously, finally, mining centralization is very, very much a big deal right now. It's very centralized today. It has been centralized for a long time. That's not necessarily news. But if it's not something that gets better, then why are we bothering with this mining thing, right? If we have two pools who control the Bitcoin network, well, you're kind of better off using Ripple. Sure, Ripple has 6 servers run by Ripple that control the Ripple network. But how is that different if we only have two pools running the network? Now, I don't think it will remain that bad. And I've said a few times that if I thought mining centralization wasn't going to get better, I would have stopped working on Bitcoin a while ago. But it's something that we need to work at. And it's something that as a community we need to be focused on and thinking about how can we proactively address this going forward.
Yeah, which is a great segue to your project, BetterHash. But to sort of set this up a little bit, what is a mining pool? For the benefit of my audience, what do they do and why do they exist?
Yeah, so when you think about a miner, right, you're a small miner, you have maybe 0.1% of the network hash rate, which I guess these days is actually a very large miner, but you have 0.1% of the network hash rate. At the end of every month, you have to pay your power bill. Well, you're not going to pay your power bill if you get one block every year and you might go 3 years without a block. You're just not going to be able to afford it. So instead, miners do what's called pooling. They all get together. You have a number of different miners who all pay their rewards into a pot. And when any one of them finds a block, instead of getting the entire block reward, it gets distributed out to all of the pool's users, proportional to how much hash rate they have. This way, someone who is a moderate-sized miner, a smallish miner, gets very consistent payouts on potentially a daily basis, maybe even an hourly basis, and can function and as a business and have kind of reliable cash flow.
You're reducing the variance of the mining reward, in other words.
Exactly. That's the primary function of pools. They also serve a number of secondary functions, primarily optimizing block propagation and optimizing the infrastructure behind block creation that miners don't necessarily want to deal with, right? If you are a miner who maybe doesn't know that much about Bitcoin, you're interested in Bitcoin, you think it's cool, you invested a bunch, you know something about power and power distribution, but maybe you don't know a lot about Bitcoin software, you can kind of let the pool handle most of the optimization of block propagation and block creation and all of these other factors and Bitcoin management and whatever else that you don't necessarily want to be responsible for. You can let someone else deal with that and you can focus on what you're good at, finding cheap power.
Okay, so let's get into the actual specifics of how a mining pool works. How does a pool know how much work you did if you're a miner that's contributing to that pool?
Yeah, so mining pools, essentially what they do is they use a lower difficulty as proof of work. It turns out we have this great thing in Bitcoin where if you're doing work on a block, you're trying to find a block, you won't obviously always find a block. Most of the attempts you do, you're doing whatever terahashes per second. That's millions and billions and trillions of hashes per second going on in the network all the time, and the vast majority of them obviously don't get lower than the target, right? Bitcoin has a difficulty which determines if you want to create a block, your hash must start with a certain number of zeros, and most of the hashes you try aren't going to start with that many zeros. But you can do a clever trick and say, all right, well, it was supposed to start with 10 zeros to make it a valid Bitcoin block, but if you start with 9 zeros, you send it to the pool anyway, and the pool can look at how many times you find potential blocks that start with still a lot of zeros, but slightly less, to calculate actually how much work you're doing. It's a convenient proof because it still takes a lot of work to generate something that starts with 9 zeros. It's not a full block, but it's still a lot of work, and you can prove to the pool, yes, I am working on the work you want me to work on that will pay out to you if it is a valid block, and here's proof of it in a relatively simple way.
And what is Stratum? What is this protocol between the pool and the client and the actual machines, I guess?
Yeah, so Stratum has been around about as long as pooled mining has been around. It is the protocol largely which all devices doing any kind of mining connect to and speak to the pool over, right? So your little ASIC device, your Bitmain S9, your Dragon Mint T1, whatever it is, it has a control board on it, which runs some variant of CG Miner or some other software, which speaks Stratum, connects to the pool, and over that Stratum connection, over that protocol, gets work from the pool. The pool tells it, hey, here's what I want you to work on. Here's the information about how you build a Coinbase transaction, how you put the block together. And then it also, over that protocol, can submit back these shares that it found, these things that have almost enough work, but not quite enough work to be a valid Bitcoin block, as proof that it's doing work for the pool.
Yeah. And what are some of the weaknesses of Stratum?
Yeah, so Stratum's been around a long time, and I think everyone readily admits that it is not so optimal. It has some relatively weird encodings in it. So it has it is almost all writing hex over the wire, but it's actually JSON encoded hex because I don't know, that it's just kind of useless. It has some really weird stuff. I mean, it's not well documented. There's a number of details in Stratum where there's not really a formal spec. Various people have tried and written together various things, but there's a lot of pieces that just aren't written down anywhere. It is completely unauthenticated. So I think this is actually kind of a major issue that as a network we face today. There's a lot, I mean, almost all of the hash rate on the Bitcoin network is pointed at one of a number of different pools. And if someone were to hijack the pool, either the pool server, or the pool's DNS server, or the pool's IP space, or whatever it is, then they could steal all of that hash rate for essentially until all of those miners went around and power cycled all of their ASICs, which would obviously be a rather massive undertaking. And I mean, they could use that to do a large scale 100% of network hash rate attack for, maybe 5 hours, 12 hours, 24 hours until kind of everyone gets a chance to, or at least a majority of miners get a chance to address the issue. And we've seen these kinds of attacks, right? We saw this with the MyEther wallet hack where someone hijacked Amazon IP space, BGP hijacking. And we've in fact seen this specific attack against some altcoin pools a long time ago, maybe 4 or 5 years ago. But we haven't seen it anytime recently, but it's still potential very large angle for attacking the network at a large scale because Stratum is completely unauthenticated. It's just raw TCP sockets and bytes going over the wire. There's no encryption, no signing, no anything.
So you've been working on BetterHash for a while. Can you tell us what got you started on that and what the goals of BetterHash are?
Yeah, so there's kind of 3 tangential goals, right? So there's, replace Stratum, right? Stratum has all these issues, like it to be authenticated. We can make it more efficient. We can make it more, we can have a specification for how it works, all these wonderful goals. So that's definitely one of the main goals. The second goal kind of relates to another protocol, which is called Get Block Template, which is the way pools get, a block template, candidate block with all the transactions in it and everything else out of Bitcoin Core. which is also a particularly inefficient protocol. It is also JSON encoded hex for some terrible reason. It's relatively hard to make changes. So Git block template required a number of changes for Segwit, which meant a lot of pools had to have various software changes, and largely for no reason. I mean, there's no reason that pools want to have that complexity on their end. It should instead be in Bitcoin Core. Yeah, so replace Git block template, which is another valuable goal. So these are both kind of goals that people have been talking about forever, but there was never kind of a strong desire to go out and do it because, I mean, there's these issues and they're really annoying, but replacing it and trying to get it adopted sounds hard. But there's this third thing that also people have been talking about for a while, but might make it actually really worthwhile. So today, as I mentioned, right, over Stratum, you get the block templates. You get information about how to build the Coinbase and also information representing all of the transactions in the block. This means that the end user miners have largely no control over what they're mining on. This is entirely left up to the pool. The pool could either, if they chose to, or if they were in some way compromised via a number of different vectors, could have the users do anything they wanted, whether it's a selfish mining attack or a 51% attack or censor transactions or double spend, any kind of attack you could think of. The user has no ability to stop the pool from doing that unless they're, very aggressively monitoring switching pools and other things that no one does, and it is largely impossible for various reasons. But there's little reason for that to be the case, right? So I mentioned the primary reason pools exist is to do reward splitting and even out variance of payouts. Well, that is completely unrelated to transaction selection and block template building. So this protocol is designed to allow users to run their own full node. If they want, can run their own full node. They can build their own block template, select their own transactions, not censor transactions, can select which block they're mining on to prevent a 51% attack or something like this, or prevent a selfish mining attack, and then still pay out to the pool and prove to the pool, send them shares and say, hey, look, I'm doing work, I'm paying out to you, and you can even see that the block is valid, and then have the pool split the reward just like normal, even out the variance, have all of the same business properties that they have today, but the pool has no control over what they're mining on. So in effect, from the network's point of view, the miners are now the miners again, instead of the miners being the pools. I mean, this means we could have just one pool, and it wouldn't really be a big deal. Yeah, you could have one pool for the entire network, and no one would really care.
Yeah, just to sum up, what you have with BetterHash is you are giving the control of creating the block back to the actual owner of the mining hardware instead of the pool that gets to decide what transactions get to go in. Is that
exactly
right? That sounds fantastic. And is that something that mining pools or users have been asking for? What sort of brought you to create it?
Not really. There's certainly a lot of questions. So I mentioned that kind of one of the other aspects of what pools do is optimize a lot of the software on behalf of their users. And so for this reason, I think a lot of pools don't have much interest in adopting a protocol like this when it requires them a lot of additional effort, like managing and running a full node. That said, if we get some fraction of the network to adopt this, or if we get larger pools to adopt this, there's some efficiency advantages in adopting a protocol like this. So if you get larger miners, not necessarily larger pools, but larger miners to adopt something like this, even if small miners might not, or might not as much, you still get almost all of the advantages of the decentralization properties of it, while not necessarily putting a ton of additional burden on users who might not want to do something like this, and also providing them better security. Remember, I mentioned we're like adding these signatures and whatnot to make Stratum more secure, the Stratum replacement more secure. But like this would just be such a massive win for decentralization, right? This is something where mining centralization today is one of the bigger threats to the network in the long term. And if we don't do something about it, that's going to be a problem. And so designing a protocol like this, there's a number of small things that you can do to make it a little bit more efficient, a little bit easier to use for people. And then making sure that this is an option available to people who want it or who might choose to use it at some point in the future. For whatever reason, maybe the pool is actually doing some attack they don't like or censoring transactions they don't like. They could switch to a protocol like this. So making sure it is an option that people have, and also providing additional features that people might want, hopefully might, in the long term, drive some level of adoption of it, because, that would solve one of the bigger issues facing Bitcoin today, or facing Bitcoin in the long term, at least.
Yeah, and one of the things that I'm hearing here is that you are separating the centralization of the payout, right, which you kind of need with reducing variance, with the decentralization of the transaction selection, because they were both conflated, but now you're separating them. That's
exactly
a huge win.
Yeah, there's no reason for those to have been conflated in the first place. It was just a simpler way to implement all of this stuff.
So, using your protocol could, if I, as a miner, if I had 3 Dragon Mints or something like that, would I be able to use the pooling or the variance reduction and mining rewards of one pool and the work of another, right? Like the actual optimization.
Yeah, exactly. So you can, because these are completely separated, you can choose to run your own full node that you get work from, or you could choose to use someone else's. Say, because pools try to do this variance reduction, you can't necessarily go stand up a pool and have people want to use it, because you would still have very high variance. You don't have many miners on your pool. But once you split them out, well, anyone can go stand up a Bitcoin D, say, hey, look, I'm running this. I've optimized it. I've spent a bunch of time thinking about this. You should use my work server. And people could just use it right away. There's no barrier to entry into that market, even though there would still be a barrier to entry into the payout separation or variance reduction side of the thing. But again, the network doesn't really care about that. That's a private contract between the pool and the miner. And, if the pool screws the miner, sucks for the miner. It's not really my problem.
Yeah, if I were a miner, I would totally want more control of what transactions get in. We know that there are mining pools that charge extra money to include certain types of transactions or whatever. And that's a separate item than the variance reduction. So they really shouldn't have that. It should be up to the individuals that are actually mining. So it seems...
And especially if you want to get, if you believe in Bitcoin and you want to see it succeed in the long term, and then this is an issue you probably should be worried about. And so if you're a miner and you say okay, well, we want to see Bitcoin succeed in the long term, and you should be considering, can we use a protocol like this? Can we find a pool who might want to implement the pool side of it, and then either run our own full node or, find someone we trust maybe a little bit more to run a full node for us.
So I did read through your BIP, for BetterHash, and I wanted to ask you a few questions about it. First one is weak blocks. What are weak blocks? And can you describe that for the audience and what benefits we get out of utilizing weak blocks?
Yeah, sure. So one of the kind of weak blocks is kind of an old idea, and it's been proposed in various forms, but at a high level, you think about the shares that users are submitting to pools, right? You have these blocks that carry proof of work, even if they're not quite enough proof of work to be full Bitcoin blocks. Well, you can also send those around in some form, right? You could send those to people and say, hey, look, I did a bunch of proof of work. So, I'm not DOSing you or anything. It would cost me way too much. So here's a example block that I'm working on. And you can use that for various things that people have proposed, but specifically in this protocol, it's used to very efficiently relay blocks to the pool, right? So as I mentioned, because right now pools do a lot of work on optimization, it is important in the protocol for pools to still have some ability to do a lot of that optimization around block propagation and things like this, even when the users are running a full node. So by using this weak block thing, we can send a block to the pool, say, look, here's a share. It's maybe a bit more difficulty than a normal share, but it's still less than a block. And then every time we find something that meets this difficulty, we can send a compressed version of the block. So we can say, okay, well, here's a new weak block, and here's just the differences from the last one. And this works very well, right? Because the mempool doesn't change completely every second. New transactions come in, some transactions get replaced. So changes, at least during the duration of one block, are relatively small. And by doing this, we can, when you actually find a block, very efficiently send it to the pool, because we have this great compression. We can say, okay, well, the last weak block I sent you, I found a real block now, and here are just the differences from the last weak block. And then the pool can receive blocks when they're found very quickly from all of the miners, and then do any kind of block propagation optimizations that they want to, because they're going to very efficiently and quickly receive blocks from their actual miners.
Yeah, this reminds me a lot of Git, where you store the delta with the last sort of saved state, and you're only transmitting that as a way to make it a lot more efficient. So
exactly, this stuff tends to work very well now.
Yeah, and Git is sort of the other quote unquote blockchain-y thing out there that's actually decentralized. So I like that there are parallels here. Let's talk a little bit about version rolling. Can you tell us a little bit more about what that is and how this protocol enables that?
Yeah, so this gets into a little bit of sticky political drama, right? There's the old Asic boost patent, right? So the Asic boost patent was held for a long time privately, and was more recently purchased as a part of the Dragon Mint operation. It was purchased and released under a relatively permissive license. There's still pending questions about the applicability of that license in some scenarios, but all that to say, people want to do more overt Asic boost. And the way you do the simple, easy, very easy to implement, cheap to implement version of Asic boost is you change the version in the header, right? So within the Bitcoin block header, there's various fields. Towards the end, or maybe right at the end, there's the nonce, which is kind of the traditional thing that you just fiddle every time you try to find a hash. It is literally there only for you to fiddle with it. That's its explicit purpose. But in order to do Asic boost, you want to change things that are in the first half or the first chunk of the block header. And the most obvious candidate there is the version, right? So there's this version field. It can be mostly anything. There's some restrictions due to various earlier soft forks, but there's not really any rules, mostly, as long as you set the first few bits, to what it can contain. And so when people want to do Asic boost, they want to just twiddle a bunch of bits there. This is a way more efficient, way simpler way to implement Asic boost. And one particularly interesting thing you can do if you want to play with the version is you can skip sending any of the Coinbase transaction information to the miner. Right, so right now, miners, because they mostly focus on only rolling the nonce, they don't have enough bits in the nonce. They don't have enough work to do just from the nonce in order to kind of constantly mine. So instead, they have to have information about the Coinbase transaction so that they can twiddle some bits in the Coinbase transaction, calculate a whole new Merkle route, whole new Merkle path, and then have a new header they can work on. That's pretty inefficient. I mean, it works fine, but it also means that things like SegWit, things like having different bits in the Coinbase transaction might end up needing a firmware upgrade on all of the miners. And that's just a mess. That's a pain in the ass. We don't ever want to have to upgrade firmware on miners just so that we can have the type of fork or commitment or whatever that we want. So instead, what you can do is you can actually, there's enough bits between the version and the nonce that you can go and just mine using just the header. And then remember, there's a timestamp field in the header. And so as long as you can get enough work out of the version and the nonce for a full second of work, you can just increment the timestamp once a second. So this protocol has a specific mode for enabling miners to do this, where they only get headers. It's a lot less data. It's a lot less complexity to implement. It's a lot less bandwidth. It's a lot less everything. Great for miners. And they can just twiddle the version, the nonce, and then increment the timestamp once per second.
So they're essentially using part of the version field as extra nonce space instead of the Coinbase transaction.
Exactly.
Well, that sounds fantastic as well. Another one that another big part of BetterHash is the authenticated communication, and I noticed that it was using the SecP 256K1 curve with the same style signatures and everything with ECDSA. So can you tell us a little more about why you chose that instead of, I don't know, something else, I guess?
Yeah, well, I mean, you know, the Bitcoin space has that software deployed everywhere, right? So if you're going to design a new protocol in the Bitcoin space, making sure that everyone kind of already has the software ready for it is a particularly useful goal. And kind of everyone uses libsecp256k1 to implement all of the signature verification and creation. And so just using something like that is pretty natural because the software is already widely deployed, especially in the Bitcoin ecosystem, and people aren't going to have to figure out how to use some new curve or some new software package that they're not used to.
And does it go through as a dir signature, or is it like something? Is it?
No, I mean they're the compacted signatures, so not the insane DER encoding thing.
So it's just straight 64 bytes.
Yeah, just straight 64 bytes.
Okay, all right, great. Because that dir is one of those things that drives me absolutely bonkers.
Yeah.
All right.
No one likes DER.
The other part that of your proposal that I wanted to ask you about is the Coinbase output modification or something like that. There's 2 bits in the protocol version that you can set, bit 6 and bit 7, which let you modify the Coinbase transaction in some way. Can you tell us more about that?
Yeah, so there's a lot of, almost all of the complexity, in fact, of the protocol is around how you build the Coinbase transaction, right? So you're taking information from the pool about where you have to pay out, and you're taking information from Bitcoin Core about, SegWit commitment and input information in the Coinbase and various other things. And so there's a lot of rules about, okay, well, you can take these bytes from here and these bytes from here, and you can concatenate them, and then you have these extra bytes here that you can play with, and then you can add these outputs, and they can only be of 0 value, but then you have to pay the rest out here, and they have to come in this order. That's almost all of the complexity to it. And so the bits that you're pointing out here in the work protocol are, in fact, the bits that allow you to say, hey, look, I am an Asic. I don't know how to do any of that stuff. You just tell me exactly what I'm supposed to mine on. I don't know how to connect to a pool. I'm just a simple, naive system. Or you can even say, hey, I don't even know how to build a Merkle root. Screw you. Just send me a header. I'm going to play with the version, and I'm going to play with the nonce and the timestamp, and I don't have any of the complexity. So you can set a mode and say, like, hey, I have none of the complexity implemented, and the server will respond and give you a much simpler version of the protocol. Or if you are, for example, a system that has your own full node and you want to combine work with the pool, then you have to implement all of the kind of other complexity there of saying, okay, well, here's the things I get from the pool, and here's the things I get from the work server and the Bitcoin Core, and here's how I merge all of them. And then on the other hand, I can give them to my ASICs and have a very simple protocol. But there's a lot of thought that went into kind of how that Coinbase, which servers are able to pick which parts of the Coinbase transaction, so that you can have things like, well, if someone wants to merge mine, they can have the pool server provide like a default merge mining template, which goes to the Coinbase. So the user can completely not be aware of it if they want to, or they can have their own work server also add a piece of the Coinbase transaction that overrides the default from the pool, and they can be their own merged mining client if they want to. Also make sure that there's, as I mentioned, we're not going to have to change the protocol. We're not going to change miner firmware or anything like that. If we want to add additional commitments, UTXO commitments, or Bloom filters, or SegWit version 2 commitments, or something like that in the Bitcoin block. So make sure that the Bitcoin Core is able to select the appropriate parts of the Coinbase transaction for something like that. So there's a lot of complexity there that's kind of hidden, but hence why very well specified in the protocol exactly who can pick which parts of the Coinbase.
Yeah, so it sounds like it's future extensible by having additional bits for different commitments or something like that you may want to choose yourself as a miner, or get straight from a pool or a work server or something like that.
Yeah, a lot of work went into making sure that future things we want to add aren't going to require any protocol changes. They'll just work. You just have to add the right fields, and all of the clients won't even need to be updated. They'll just know how to build the right Coinbase transaction.
Yeah, which is incredible. That makes it a lot simpler and gives you a lot more flexibility as a miner to choose what it is that you want to do, and you're not sort of beholden to a pool as far as what transactions get mined and stuff. Speaking of commitments, so Bitcoin Cash apparently has a UTXO commitment on testnet that they let me share my screen with you so you know what I'm talking about. This came on or I think it might have been published 20 hours ago. This is published on yours.org, that bastion of BCH stuff, and they apparently have a UTXO commitment inside a Coinbase transaction utilizing an op return. So I think a lot of people have this impression that this is something new and that this is something that Bitcoin Cash came up with. But as we know, this has been around. So can you talk a little bit about what this is, first of all, and you know what it requires to actually have a UTXO commitment and why Bitcoin Core doesn't have it yet?
Mm-hmm. Yeah, so this is yet another example of everything new in the Bitcoin space was actually invented between 2009 and 2011 and was just never implemented. But you'll note if you scroll down to the bottom, they have a number of links here, and one of the oldest links is, or one of the kind of more obvious links is one on Bitcoin Dev. I believe it's a link, yeah, it's Peter Willa's write-up on different forms of rolling UTXO commitments. So the basic idea here, it's a very different model from some of what people traditionally think about when you hear UTXO commitments. Instead of it being a UTXO commitment where I can go and prove to someone, I can say, look, here's the committed hash and the block header, and I can prove that I have an unspent output in the chain at that height using just this commitment. This is something for which you actually can't prove anything against. It's just a hash of kind of the whole UTXO set in a way that's efficient to, or mostly efficient to add and remove elements from. What it is useful for is something similar to assume valid. And in fact, this was kind of Peter's original post, was largely a proposal for different ways to think about doing this. So assume valid, as they mention in their yours post, is a concept in Bitcoin Core that was added a while ago, which is saying, okay, look, you're downloading the software. You know, there are a lot of people who get the software audited or look through a lot of the software themselves and try to make sure it's not doing anything funny. One of the easiest things we can give people to audit is a assume valid. And assume valid doesn't say, it's not a checkpoint. So it's not saying, okay, at this height, the block header or the block hash must be X. It's instead saying, well, here is a block hash which I know to be valid. I know that all of the signatures and scripts all pass at this block hash. And that's relatively easy to validate. You can, in fact, turn assume valid off, and that would validate it. Or if you already have a full node, you can go and look and make sure that it accepted this block or something like that. And in Bitcoin Core, if assume valid is provided, which there's a default, it will skip all of the script execution during initial block download up to that block. So you can do initial block download entirely up to a block, you know, maybe block 500,000 or something, without doing any of the script execution, which makes initial block download way faster, but without a change to the security model, right? Because it's explicitly stated there, it's just here is a block that is valid. Your Bitcoin Core node will connect any other block. You know, if there's a reorg or something through that block, it'll still go to the block that has the highest total work that is valid. It just will have to verify all of the scripts if there's a different block at that height. So, you know, we can do this all without changing the trust model. Now, Peter and various other people's proposal was, what if we have an assume valid for the UTXO set itself? What if we say, okay, we're just going to add a hash in Bitcoin Core as a default and an option that people can set that is a full hash of the UTXO set. And if we have something like that, we could have users simply check out that hash. You go connect to all your peers, you download the UTXO set that matches that hash, and then you have some hash of the UTXO set and a starting UTXO set. And you actually don't even have to download all of the blocks during initial verification with a similar trust model. Now, if you're paying attention, it's only the same trust model if they are committed to by block, by proof of work, right? So the assume valid model, you still have to have all of the proof of work. So there is still some trust in that you can audit this value easily. So hopefully the Bitcoin Core developers aren't lying. And if you think they might be, you can turn it off, or you can compare it against other full nodes or whatever else. And also the miners would have to be doing a very, very large reorg in order to make this somehow utilize this to get an invalid block accepted. So in order to have this kind of UTXO sync model have the same trust model, you need a UTXO commitment, which is what the BCH folks demonstrated on their testnet. And then you also need this kind of assume valid value in the client, and you need to implement all of the logic to download a UTXO set, hash it, check that it hashes the right value, and then implement all of the kind of syncing, set that as your UTXO set, have all of the peer-to-peer messages, make sure they're not a huge DOS vulnerability, which is actually not a trivial process, and implement all of the logic to sync based on that and have people audit the hash value there. They haven't done any of the later steps. So they've only actually done the step to generate the commitment and put it in the block header at some point, which I believe was largely already done in Peter's original post, or if not done in his original post, which it looks like maybe it wasn't done at the time. I know it was done later. So they're making progress towards trying to use this kind of model of downloading the UTXO set instead of downloading the UTXO set directly and comparing it against a known good value, instead of downloading the entire history of all the blocks and generating the UTXO set. But still have a long way to go. And the work that they've done, while really cool work, is not all that novel. So they talked a little bit about they don't actually talk in too much detail, but they talk in a small amount of detail about the crypto they're doing to create this set. There's a ton more detail on Peter's original post, and I assume on some of their other further reading links as well. I obviously don't know enough to comment on their approach versus the other various approaches and how much, if any, it differs, aside from maybe just using a different curve.
Yeah, it's interesting because so much of what you can do with these commitments, like the SegWit commitment, obviously you can prove certain things about which transactions are included in a block and so on. And you wouldn't think that makes a big difference, but when you can prove things, it ends up adding a lot of value to.
Yeah, and that's why these kind of commitments are really only useful for the specific case of doing this fast sync. They're not a way to prove inclusion in the set. So I can't give you the UTXO commitment, give you a UTXO entry and say like, hey, look, here's a proof that I am in the UTXO as of this height. It doesn't actually work for that. So instead, it's really just useful for this kind of initial fast sync thing.
Yeah.
So it's a different type of UTXO commitment, despite using the same name.
Sure. It's interesting the direction that they seem to be going. What's your opinion on what they're doing? By the way, like they seem to be adding, like making script more complicated? I mean, I'm expecting them to release some Turing complete.
I'm not. I mean, they didn't make it materially more complicated is the thing, right? Like they re-added some opcodes that were removed a long time ago, but to limited gain. I mean, these are things that there's no one, as far as I'm aware, jumping at the bit to go use these in anything, right? They're not like, there's no one standing there saying like, well, we're going to implement this new fancy layer 2 protocol using BCH, but we need these new opcodes. Well, no one is. There's no one doing that. So
but they have 32 megabytes of space, Matt. They want to use it.
Yeah, right. Until anyone starts using it, and then it's a problem. I mean, look, they're doing work. They're doing things. I am curious. I'm curious what kind of adoption any of the work they're doing will get, right? They have these new opcodes and various other things. I'm curious to see anyone actually start using them for real projects that people, want to use and are providing real utility to people. But they are doing, they're experimenting with various things, and I think that's cool. And certainly the UTXO commitment for faster initial sync is something that's been bounced around a lot and is a really cool idea. I will be interested to see them deploy a finalized version that actually uses it for downloading and then does so securely without major DOS vulnerabilities in the peer-to-peer logic. But it is a really cool idea. It's been around for a long time, and I'm excited to see someone actually finally going in and trying to do it.
Is that why it hasn't been implemented in Bitcoin Core, because of the different trade-offs and vulnerabilities? And
I think there is a discussion to be had about the slight differences in the trust model of this versus something like assume valid versus not using something like assume valid. Because assume valid says that, so I mean, with the commitment and with assume valid, or with an assume valid like parameter for assume UTXO, which is I think the common colloquial term for this type of commitment is just assume UTXO. It's very similar, but there's various discussion around making sure that this is done in a way that is still really easy to validate. It's still really easy for people to check that the value that is provided by default is correct, and make sure that it doesn't actually make checking the value impossible, right? So you can't just have all nodes sync by doing a UTXO state snapshot and never can validate because the chain is too long to actually go validate the thing. And so everyone just trusts that this thing is right. You do want the ability to go validate it, even if it takes a while. So making sure that you don't end up in a scenario where it's just impossible to validate these things is an interesting thing that's been discussed at various points. But I think ultimately the biggest reason why this doesn't exist yet in Bitcoin Core or in Bitcoin is largely just because people haven't got around to it, right? Initial block download is still relatively fast. I mean, it's certainly not nearly as fast as people would like it, but to be. But for people who are capable of running their own full node, they have hardware that they want to dedicate to something like that. The initial block download cost is not the kind of biggest barrier to something like that. So, I think this is probably something that will get implemented in Bitcoin eventually. It's a lot of work to make something like this really good and get it exactly right the first time. But maybe we'll learn something from the BCH folks actually trying to implement something like this.
And that's a very good way, a very positive way to look at it. All right, so we're coming up on almost an hour. Let me see if there are any questions from the audience. Let's see, where did I put that window? I have you ever have 200 tabs open and you don't know which one it is? Oh, thank you, The Bad Virus, who says Monero for the win. That's kind of funny. What's your opinion? I mean, I think you were working on a Lightning Rust thing. How's that going? Where's that at?
Yeah, I mean, that's one of the like way too many projects I have going right now. So I started it largely as a way to learn about Lightning and a way to learn about Rust. I mean, what better way to learn about both than sit down and implement something in them? So I made a lot of progress on that. It is structured in a way that is a little bit different from a lot of the other Lightning implementations, right? So it's a C callable library, so you can embed it in almost any existing wallet you might have in any language you have, anything like that. It's designed to be really embeddable in any existing wallet you might have. But, it's obviously still pretty early. It's not something that's been like compatibility tested with other clients. It's not something that's ever actually generated live transactions on a testnet or anything, even if it has extensive test cases. So, it needs a lot of love. I'd love to get more contributors. There's various folks who've showed up and said that they intend to contribute. Haven't seen a lot of progress on some of that yet, but it's, it's an interesting learning test bed, and it's designed to be compatible, at least eventually, with all of the other Lightning implementations. And certainly taught me a lot about exactly the internals of how Lightning works and all of the various trade-offs they've made and have yet to finalize exactly which direction they want to go in various things, even if I don't have as much experience actually operating Lightning nodes yet.
I mean, I don't think anyone does. It's all still brand new, so
that's true.
It'll take some time. But I mean, I can tell you there's a ton of interest in this sort of thing. So if you guys are interested, this is where you can get in on the ground floor on a Lightning implementation, is through Matt's Rust implementation. What's that called, by the way?
It's just called Rust Lightning. If you go to github.com/rust-bitcoin, there's a whole series of actual Bitcoin libraries written in Rust. So there's some lower level stuff, there's some address parsing stuff, there's the Lightning implementation, there's a progress towards an SPV client. A lot of the ones that are kind of higher level, like the SPV client and like the Lightning implementation, are still pretty fresh. They're still pretty new. So if you want to learn a little bit about Rust, you want to learn about various details of Bitcoin protocol stuff, they can use contributors, and you don't have to be an expert to write them. I'm certainly no Rust expert myself. So, if you want to, get in on the ground floor, as it were, on some of these, there's definitely a lot of opportunity to do it via the Rust Bitcoin project.
Okay. Well, let's take some time to wrap up. Are there any other projects that are coming down the pike that my viewers should be aware of?
I mean, there's, the continued work on Bitcoin Core, which is making a lot of progress. There's a lot of new contributors in that space. There's a lot of activity going on there, which has been really great to see over the last number of months. So, look forward to whatever the next version of Bitcoin Core is. Lots of good code cleanups, and starting to get to the point where there's like internal APIs in Bitcoin Core that are nice and robust, and like you can extend Bitcoin Core and like write stuff in that runs in Bitcoin Core, and it's like maintainable and uses APIs that are actually APIs and not like hooking random stuff inside of it. So, there's a lot of great work going on there, although admittedly a lot of it is kind of behind the scenes and whatnot. Lots of good performance improvements, all of that stuff is keeps coming.
Yeah, I want to make my own block explorer so I can have my own to look at instead of trusting somebody else or compromise my privacy. I can't find one that works with Bitcoin D that's easy to install, and that's been very annoying.
Go take a look at the new indexing stuff that Jim Posen's been working on.
Okay, does it have an address index?
No, but actually writing an address index using the framework that he's built for it would be pretty easy to do, and would be completely, it would be updated in the background thread, updated async, kept up to date automatically for you. The framework does a lot of the work for you, and uses internal APIs, which, okay, they're not for public consumption yet, but they're actually reasonable to use. They're not going to ideally probably fundamentally change every 3 months, right?
Yeah, ideally I'd have like a ZMQ connection and I can just query for various stuff and use that to display whatever blocks. Yeah, I mean, just all of the block explorers out there just aren't very good, and they're very difficult to install or require, I don't know, Bcoin or something like that. And I don't know, I don't want to have to deal with installing all of that.
Yeah.
So that's something on my wish list. Maybe I should open an issue or try to contribute or something. All right. Anyway, thank you, Matt. His project is called BetterHash. Let me share the links and at least show you where all the stuff that we talked about is.
I sadly don't have a website for it yet, but
yeah. Well, but this is in your. Let's get rid of this little Microsoft notice. This is the BIP's repository of the Blue Matt. That's Matt's GitHub account, and this specifies exactly what the protocol is. It allows for much better miner decentralization, and that's really good. He also wrote this Bitcoin Dev mailing list post, and you can read through his reasoning here. And these are, I'll put these in the show notes. Please check them out. Matt, thank you so much for being here. I enjoyed this conversation very much, and hopefully my viewers did as well.
Yes, thank you very much for having me.
Okay. This song is done. See ya.